In 2026, global power is calculated in teraflops. Artificial intelligence has emerged as the most valuable strategic resource on the planet, rules deciding who gets access. The United States and China are now the primary competitors in this space, locking their national security and economic futures into a struggle for dominance. This competition is deciding who builds and manages the digital architecture that modern nations now run on. Historically, the United States maintained an advantage through its control of advanced semiconductor fabrication. The physical engines driving modern AI are graphics processing units, or GPUs. These dense, highly specialized microchips proved uniquely capable of handling the massive parallel calculations required for machine learning. The U.S. government treated these chips as physical choke points, implementing strict export controls to block Chinese laboratories from acquiring the latest hardware. Over time, policymakers adjusted these rules, attempting to secure national defense while still allowing American tech companies to sell products in the global market. The U.S. approach was built on treating AI like a physical commodity, one that could be secured, tracked, and denied at a border. Faced with hardware restrictions, Chinese companies accelerated domestic production. They poured capital into heavily automated semiconductor fabrication facilities to build alternative supply chains. But a different strategy emerged that didn't rely on hardware at all. Chinese laboratories began releasing highly capable open-weight models. An open-weight model is an AI system where the core parameters are publicly available. Anyone with computing power can download and run the software. Unlike a pallet of microchips, these digital weights don't pass through customs. They bypass national borders and regulatory firewalls. Once a top-tier open-weight model hits an online repository, it replicates across global servers in minutes. Reversing that release is technically impossible. Governments can embargo physical hardware, but software travels at the speed of the internet, often moving faster than international policy. Realizing hardware bans are no longer enough, the U.S. government introduced new oversight measures directly targeting the most advanced software systems, known as frontier models. Proponents argue this software-level regulation is necessary to protect national security interests and prevent the misuse of powerful AI. Critics warn that heavy domestic restrictions might isolate American developers and slow the very innovation that secured the U.S. lead. At the same time, strict export licensing for software motivates foreign competitors to rapidly build their own fully independent AI ecosystems. Expanding the battleground from chips to software shows that traditional geopolitical controls struggle to manage digital assets. Beyond the creation of these models, a second race is underway to see which systems the rest of the world actually uses. These platforms are becoming the foundation layer for global healthcare, finance, and scientific research. To house the computing power required for these systems, hundreds of billions of dollars are flowing into massive global data centers. Whichever nation's models achieve global adoption will set the standards and rules for the world's digital infrastructure. Currently, the United States holds a lead in physical chip design, frontier research, and private investment. China continues to close that gap through domestic infrastructure projects and a rapidly expanding open-source ecosystem. Technological leadership is historically cyclical. A lead in one decade can vanish in the next as new standards and alternatives emerge. Ultimately, global influence is determined by whose artificial intelligence the rest of the world chooses to power its machines.